So for this lesson, we're going to be continuing on with our trig functions, and we're going to be investigating the models a little bit. We've kind of alluded to this lesson in previous lessons, but we're just going to look at our equations and make some final connections between sine and cosine. So before we start, let's do a little bit of a warm-up to refresh ourselves with how to find our key features. So for our warm-up, we are going to write the equation for a sine function with an amplitude of 1/2 and a period of 45 degrees. So when I see my amplitude there, my amplitude of 1/2, that is giving me my A value. So if I know I have amplitude of 1/2, that means that A is equal to 1/2. So as soon as I find the amplitude, I can immediately translate that to the A value. The next piece of information I'm given is that the period is 45 degrees. Now, if the period has changed from 360, that means I have a K value. So how I find that K value is that the period is equal to 360 multiplied by 1/K. And I'll give you a little bit more of a simplified version of that equation later in the lesson. But our period was 45. Now I'm just going to divide both sides by 360. So we'll have 45 over 360 equals 1/K. Now I'm just going to reduce that fraction there. So we'll get 1/8 is 1/K. And then you can either just cross multiply, or I can flip both fractions, whatever you're more comfortable with, and I'll get that 8 equals K. So because it doesn't mention any phase shift or horizontal translation, or any vertical translation, or any reflections, we can just assume that there isn't one. So if it's not mentioned, we just assume that those transformations are not happening. So now let's add these to our equation. Yes, you can do that, Ethan, and that's what we're going to do down here. But up until this point, I had been doing it that way. So I just wanted to make sure I did it one more time for consistency, but you're absolutely right. And that's what we'll be doing moving forward. But I just want to make sure everybody knows where this stuff comes from. So now we have an A value of 1/2 and a K value of 8. So let's fill that into our equation. So f of x is 1/2 sine of 8x. And that would be our final equation. So now let's continue with this. So we're going to be looking at some graphs and determining their equation. Yes, Dimitri, do you want to type your question in the chat? We can leave it like that. You could have also written this like this. But because there's no D value, I can just write it like this, a little simpler. But if there was a D value, then I would have to have the extra brackets there. Okay, so here are the steps that we're going to use. First, we look at our equations with the transformations. So we have y equals a sine k times x minus d plus c, and y equals a cosine k times x minus d plus c. So the first thing that we'll do, this is all very similar to the past couple lessons, is first we'll determine our axis of our curve. And our axis of our curve, as soon as we find that, that's immediately our C value, which is really convenient. Next, we're going to determine our amplitude. And as soon as I have my amplitude, that's my A value. So I can just plug that right in. Then for the period. So up until this point, we were writing the equation a little bit differently, but K is just 360 over our period, which is what Ethan was talking about earlier. And basically, this is just the equation I was using rearranged, So I had the period, oops, I don't know how to spell, equals 360 times 1 over k. So then we'll have period equals 360 over k. Move the k over and divide by the period. So we end up getting the exact same thing. No, Dimitri, it doesn't matter which one you use. You could absolutely use this one, which we had been using up until this point, or rearrange it. It's really up to you. One has a little bit more algebra than the other, but they absolutely represent the exact same thing, so it's totally up to you. I just want to make sure you see both for consistency between lessons. So then we determine the phase shift. So this is the one we're really going to be focusing on today. And if I'm looking at sine x, sorry, again, the signs double up. I have no idea why that continues to happen. For sine, we always look at where our original point of 0, 0 would have started because our sine curve starts at the origin. And then if I'm looking for a cosine function, I look where the original point 0, 1 has now moved to. So remember for my cosine, I start at a maximum and go down, whereas at my sine, I start at the axis, go up and down. Then for 5, we determine if there's been a reflection. If there has, then we add a negative to the a value. Okay, let's get into some examples here. I think that's the easiest way to go through these. So for example 1, we are going to write the equation for sine and cosine for the following graphs. So let's start with the sine one. So the first thing we're going to do is we're going to find our axis. So if I look here, the line that cuts my graph in half is at 0. Now, if it's a little bit hard for you to see where the axis is, there is a way that we can find it. So I can count how many units I have from my maximum to my minimum. So I'd have 1, 2, 3, 4, 5, 6, 7 to 8, 9, 10, 11, 12, 13, 14. So because I have 14 total and I have 7 in each of these, it's at 0. Or I could even take my maximum minus my minimum and divide that. That's another option too. Okay, so because my axis is at y equals 0, I'm just going to keep track of all of this. That's telling me that my c value is 0. So as soon as I have my axis, I immediately have my c value, which is fantastic. Next, I'm going to look at my amplitude. So my amplitude from my axis to the top is 7. And because it's 7 on both, I know that I got my axis correct. So amplitude of 7 tells me that my a value is 7. So that's great. Next, I'm going to look at the period. So I'm going to look and see how long the period is. So my sine starts at the axis and goes down through the axis and ends back here. So how long is the period there? So it ends at 450 and starts at 90. 450 minus 90 is 360 degrees. So my period is 360 degrees, and that just means that my k value is 1, but I'll go through the process. So k equals 360 over the period, which is 360. So k just equals 1. We'll go through and do the whole process just so you can see it each time. And finally, my phase shift. So how far did I move over? I usually would be at 0, but I've moved over 90 degrees to the right. Finally, I checked to see if there was a reflection. So because my sine starts here and goes down first and then up, that means that we do have a reflection and it's upside down. So we do have a reflection in the x-axis, which means A is negative. So now that we have all of that information, let's put that all into an equation. So we have that f at x equals, we had a reflection in the x-axis, and how I knew that was because sine typically goes like this, but because it goes down and then up, that means it's been reflected. Yes, Jerry, do you want to type your question? My A value was 7. Then I'll have sine my K value, which is 1, X. Then we're going 90 to the right, so it will appear negative in our equation. And then our C value is 0, so we have a plus 0 at the end, so we don't need to write that. So the phase shift, there's two different phase shifts I could have written. So because my sine usually starts here and usually goes like this, that's where sine usually is. But now it's here and goes down like that. So that means I picked it up and moved it over to the right. If I had more of my graph, I could have saw maybe some more of it on the left-hand side and maybe picked a different phase shift. But that's where I got that number. So again, my sine usually starts here and looks like this. Now it's upside down, so I know that there was a reflection, and it's starting here, so I know that it was moved over to the right 90 degrees. Okay, let's do the cosine one now. So there's a lot from the sine side that we can use again for cosine, but I want to go through the process just to ensure that everybody knows what they're doing. So again, the first thing we do is we find our axis. So we have an axis at y equals 0, which tells us that c equals 0 again. Next, we have an amplitude of 7, which tells us that a equals 7. So same thing. Then again, we have a period of 360 degrees, which tells us that k equals 1 again. That's consistent as well. Now we'll look at our phase shift here. So now we're looking at a cosine graph. And remember, cosine starts at a maximum. So cosine starts at a maximum, goes all the way down, and back up to the maximum. So for our cosine curve, there has not been a phase shift. So because it starts right at the y-axis, there hasn't been a phase shift for our cosine curve. Next is a reflection. And my normal parent function of a cosine curve looks like that. So it hasn't been flipped upside down. It has the same shape as the parent function. So there's no reflection. So now, using all of that information, let's write out our equation for the cosine function. Now our a value is 7. Again, our k value is 1, so we don't need to write it. And we are not moving left or right, so we can leave that. And we are not moving up or down, so we can leave that too. So that is our final answer. Any questions about this first example? So the idea is that there's actually usually two answers that I could give for the equation of this graph. I can usually give it in terms of sine, or I could give it in terms of cosine. So unless the question asks you specifically for one, please give both. So unless the question specifies which one's simpler or give just cosine or just sine, ensure that you provide both answers. Okay, any other questions, or are we ready to try another one? Okay, let's try another one. We're going to do a few of these because they're really good practice to do together. Okay, so for B, the little b ended up here. Sorry about that. So for B, we have this curve, and we're going to find the equation in terms of sine and cosine. So let's start with sine. Again, we're going to identify the key features, and then from there, we'll build our equation. So the first thing I want to identify is the axis. So if I look, here's the line that splits it right down the middle. So I have an axis at y equals 5, which tells me that my c value is 5, always, no matter what. Next, let's find my amplitude. So now let's look for our amplitude. So here is 1 and 1. So it's always a good idea to double check from your maximum and your minimum just to ensure that you had the axis right. So if your amplitude for your maximum and minimum are the same, it means you got your axis right. So that's awesome. So we have an amplitude of just 1, which tells us that our A value is just 1. Next, let's look at the period. So we have a period of, so remember our sine starts at the x-axis, or our sine starts where our curve is touching the axis, or the blue line here. So wherever the curve touches the blue line is our starting point for sine. And then we do one full cycle, which brings us to 180. So that's the period. So our period is 180. So K equals, and if I go up here to find my equation, you can use either of them. I'm just going to use the simplified one, but it's up to you. K equals 360 divided by the period, which is 180. So K equals 2. Next, we're going to look for a phase shift. So usually our sine starts at the y-axis. So because this one also starts at the y-axis, it hasn't been moved left or right. It's starting exactly where it's supposed to. It's been moved up, which is okay, but it hasn't been moved left or right. So no phase shift. Finally, a reflection. So our sine, our parent function of our sine, always starts here, goes up, and then down. So because our picture here also goes up and then down, it's not upside down. There hasn't been a reflection. So I can say none. So now we can figure out our sine equation. So we'll have f at x equals, our A value is 1, so we don't need to write it. Then we'll have sine, our K value is 2. We don't have any shift, so no D value, and then our C value is 5. So that would be our final answer. Now let's do the same thing for cosine, and there is a ton of stuff here that, I'm just going to move this over. There is a ton of stuff here that continues over. So some of these we can actually just copy over and paste over, but it's kind of up to you. I just want to go through the whole process so that everybody's on the same page. So again, the first thing we do is we find our axis. So we have our axis at y equals 5, which tells us that C equals 5. Then we have an amplitude of 1, which tells us that A equals 1. I'm going through these ones a little quicker because we've already done them. Again, if I look for the period of my cosine, we start at a maximum, we go down and up, back to the other maximum, and that would be my cosine curve. So again, my period is still 180. So that gives me K equals 2, same calculation as the sine one. Next, I'm looking to see if there's a phase shift. So usually my cosine curve starts right at the y-axis. But in this case, we're starting here halfway between 0 and 90. So that means my curve used to start here, and now it starts here. So it's been moved 45 degrees to the right. There we go. And now a reflection. So the shape of my cosine curve starts at a maximum, goes down, up to another maximum. So because I have the same shape on this graph, we know that there is no reflection. So now that we've gone through all of the key features, now we can write out our equation. So our A value is just 1, so I don't need to write it. Then my K value is 2. And now I do have a phase shift. So because we're moving 45 degrees to the right, it's going to appear negative in our equation. And then I have my little C value at the end. Any questions about that process? We'll do one more and then we'll try some different problems, something a little different and a little more challenging. Okay, if there aren't any more questions, I am going to do one more example and then we should be good to go to move on to the other stuff. Okay, so here's our last one. How do we know that the period was 180 degrees? Great question. So we can check the period for both the sine and the cosine. It doesn't matter. Once I find the period for one of them, it will be the same for the other one. So for my sine, I start at the axis, go up to my maximum, go down to my minimum. Oops, I went too far. Start my axis, up to my maximum, down to the minimum, and back to the axis again. So because that went from 0 to 180, that means that the period of this spot is 180 degrees. Same deal with the cosine. So the cosine starts here, goes down to its minimum, and back up, and that was also 180 degrees. So that's where that came from. Okay, so let's do our last example like this, and then we'll do two that are a little different. Okay, so here's our equation, and we're going to go through and find the exact same thing again. So the first thing I always look for is my axis. So for this one is going to cut my graph right in half. So that means my axis at y equals 1, which tells me that my C value is 1 right away. Next, I'll look for my amplitude. So to get to my max, it's 3. To get to my minimum is 3, which means I put my axis in the right spot. My amplitude of 3 tells me that my A value is 3. Next, I'm going to identify the period. So because I'm looking for sine first, I'm going to find the period of the sine curve. So my sine curve always starts at the axis, goes up, hits my maximum, down, hits my minimum, and back to my axis again. So that went from -45 to 450. So that's a total of 400. 450. Oh, oops, 495. Sorry. 495 plus 45. So that is a total of 550 or 540 degrees. So how I got that was I went from 45 and -45 and figured out how far it was to get to 495 over here. So 495 plus this extra 45 here is 540. So that's going to give me a K value of, make sure I'm doing the 360 divided by 540. So if I go and reduce that, I will get a K value of 2/3. Next is my phase shift. So my sine curve usually starts at the y-axis here, but now it starts over here. So that means that I have moved 45 degrees to the left. Finally, I'm going to see if there was a reflection. So remember, my parent function of sine goes up and then down. So because our current function goes up and then down, we do not have a reflection. So now that we have all of those pieces, we can write our equation out. So our A value is 3. Our K value is 2/3, like this. We're moving 45 degrees to the left, so it will appear positive in our equation. And we have a C value of 1. So that would be our final equation. Let's try the cosine one now. So we start the exact same way. First, we find our axis. So again, we have an axis at y equals 1. So it tells us that our C value is equal to 1. Then we have an amplitude of 3 again. So our A value is 3 again. We still have our period of 540, which we can double check for our cosine. So remember, our cosine starts at a maximum here and goes down and back up to the maximum. So our maximum's a little bit off, but we should have a period of 540 still. So K equals 2/3. And then our phase shift. So in this case, my cosine usually starts here on the x-axis, but it's been moved over to start at 90 degrees. So that means we are moving 90 degrees to the right. Okay, and then I'm going to look for reflection. So my parent function of my cosine looks like that. So we have the same shape. It hasn't been flipped upside down. So we don't have a reflection. Finally, we can put all of this into an equation. So we'll have f at x equals, our A value is 3. Our K value is 2/3. We're moving 90 degrees to the right, so it will appear negative in our equation. And then we have a little +1 at the end for our C value. Any questions so far before we move on to some different kinds of examples? We're going to do two that are a little different. Okay, so if there aren't any questions, we will move on to our other examples. So these next examples are kind of like word problems, so they're just a little bit more confusing. So for example 2, a sinusoidal function has an amplitude of 4 units, a period of 120 degrees, and a maximum at the point 0, 9. So we need to find the simplest equation. So let's take what we can get from this equation and figure out what key features this this sine or cosine curve is going to have. So first we have an amplitude of 4 units. So that means we're going to have an A value of 4. Next, we're going to have a period of 120. So let's see what K value that gives us. So we have a period of 120 degrees. So K is equal to 360 divided by the period, which will give me 3, like that. And now we also know that there's a maximum at the point 0, 9. So let's give this a quick sketch. Okay, so I know that my maximum is here at 9. There we go. And then I know that my amplitude is 4. So I know that from my maximum to my axis is 4. So we would have 5. And then if my amplitude is 4, from my axis to my minimum, we should have an additional 4. So we're at 1. So that means that our axis is here at 5. And our max is at 9. And our minimum is at 1. So again, how I got that, I put this 9 here. And I know that my amplitude is 4. So I know in between my maximum and my axis, there has to be 4. If there's 4 there, there also has to be 4 here. So that's where all of those numbers came from. So next, we know that our maximum is at 9. So that's the maximum, the highest point it will go. So from there, we know we're going to have to go down to our minimum. And then we'll go back up to our maximum. So now we can decide which equation would be simpler. So if I look here, this looks far more like a cosine curve than a sine curve. So it would be much simpler for us to write a cosine equation. So let's write out all our key features. We already have amplitude, we already have period. We have our axis at y equals 5, which tells us that c equals 5. Sorry, I should have written that a little bit lower. There we go. We now check if there's a phase shift. So because we're starting right on our y-axis, there's no phase shift. Because I start at a maximum, go back down and up again, there's also no reflection. So now we can write out our equation. So we've chosen cosine because we start at a maximum and go down. Our A value we found was 4, and we're doing cosine. Our K value is 3. We don't have a phase shift, so we can just put X. And then our C value is 5. So that would be our final answer. So the reason I knew to use cosine was because it's asking us for the simplest equation. So I certainly could have done a sine. I certainly could have gone from here, and it also has a maximum of 9 and goes back down. But because it said that this point, 0, 9, is on the curve, I know that I have a point right here. So that would just be the simplest equation because it starts at a maximum, goes down. I certainly could have written this as a sine as well, but because it wants the simplest one, we're going to go with our cosine because there's no phase shift. Does that make a little bit more sense? So in this case, that's a really good question. So would you lose marks if you wrote a sine equation? In this case, yes. So here's where your marks would come from. I would have given you a mark because you found our A value. I would have given you a mark for finding the K value, the C value, and then putting it together. Then you would have gotten a mark for making it the simplest. So if you made a sine, that is not the simplest equation. So that means it would be incorrect overall. It is important that I give you marks for finding these because those are important skills that you need to know. But because I ask explicitly for the simplest, you have to give me the simpler one. The sine will have a phase shift in there, which makes things a little more complex. But if I just asked you to find an equation, then you can put whatever you want in there. You can do sine or cosine, it doesn't matter to me. It's just because it's specified. Okay, let's do our last example here. We're almost done. This lesson is pretty quick. So here we're given the equation of the following cosine function, and we want to write an equation for the same graph, but we want to write it as a sine function. So let's start by identifying the key features of this cosine graph. So first we have a value of 2, and that is going to tell us that we have an amplitude of 2. So I'm basically doing what we were doing before, just backwards. Next, I have that c equals 1. So I have the axis at y equals 1, like this. Then I have this 30 in here, which is telling me I have a phase shift 30 degrees to the left. And I know it's to the left because it appears positive in the equation. So that means it's moving to the left. And there's no K value, so that is it. So because there's no K value, that means K equals 1. So the period is just 360 degrees like that. Okay, so the next thing we're going to do is we're going to draw a rough sketch of this. I find these kinds of questions really hard to just visualize in your head. If you can, awesome, but I find it much easier to draw a little sketch. So here we go. So we have 1, 2, 3, 4, -1, -2. Just going to extend that out a little bit. There we go. So remember, this is a rough sketch. It's not going to be perfect, but it'll help us to visualize the situation and give us a better idea of what's going on. So the first thing we know is that our axis is at y equals 1. So let's draw our axis. There we go. The next piece of information we have is that our amplitude is 2. So let's put that in. Go. And again, it's a rough sketch, so my graph is definitely not symmetrical, but what can you do? And then I have that we have a phase shift 30 degrees to the left. So for my cosine, I'm going to start 30 degrees to the left. So we're just going to put 30 degrees here. And then I know that my period is 360 degrees. So it usually ends at 360, but I've moved it 30 degrees to the left. So I will be ending at 330 degrees. That way, my period here is 360 degrees. That's what I want. All right. So now let's draw our curve here. So we have a cosine curve, and there's no reflections or anything like that. So it always starts at a maximum, and it will end at a maximum. Right in the middle, it'll hit our minimum, and then in between there, we'll hit the axis. Oh gosh, that's not straight at all. This is why it's a rough sketch. And remember that this does keep going. We're just looking at this one little bit of it here. That's the part that we care about. Okay, so now we want to figure out where these points are. So this middle bit here, oops, is right in between 330 and negative 30. So we're going to do 330 plus 30 divided by 2. So that will be at here, 330. Go at 150 here, just to organize ourselves a little bit more. So now let's figure out where our sine starts. So there's 2 places here we can start your sine curve. So it's up to you how you want to do it. So I see one sine curve here, and that's the one I want to find an equation of. But you could have also done this sine curve. It doesn't matter. You would get full marks for both of them. It's totally up to you. But I'm going to look at this one here. So remember, our sine curves always start at the axis here and end at the axis. So they go up or down to a maximum or a minimum, then to the other max or min, and then back to the axis. So now let's find the equation of the pink highlighted part. So the first thing that we want to notice is where this is. So where does my curve hit my axis here? So that happens right in between 150 and negative 30. So that would be at 60 degrees, like that. So that is our starting point. So now let's make our sine equation. So again, from above, we still have that a equals 2. We still have that c equals 1. We still have that k equals 1. The only thing that's really changed is our phase shift. So in this case, my equation used to start here, but now it starts here. So I've moved 60 degrees to the right. And finally, our reflection. So remember, my parent function of my sine goes up and then down. But in this example, we're going down and then up. So we do have a reflection in the x axis. So now let's take all of that information and make it into an equation. So we'll have f at x equals, our a value is 2, our k value is 1, so we don't need to write it. We're moving 60 degrees to the right, so we will have negative in the equation plus our little c. So that is our final answer. Any questions about that? Okay, so if you don't have any questions, I'm just going to turn off the recording.